So the hydraulic rotator on my blower quit working, and I decided to tackle this myself. Turned out it was the solenoid valve that was giving me trouble. So I took the solenoid valve off, then I took it apart, and as you can see, there's quite a bit of corrosion and dirt and buildup on the magnets and on the armature itself. And so I started off by pulling it all apart, and here you can see I'm pulling out the O-rings. There's 4 O-rings that seat directly against the valve body on the back of the snowblower, so those O-rings have to come off so I don't lose them. I use a lot of brake clean when I'm cleaning hydraulic parts, and the valve block itself here didn't appear to have any issues. It was clean. There was no appreciable wear of any kind, but I always clean everything, so I cleaned that up, degreased it, and then did a few more shots and then set it aside. I like to use the blowgun to dry off, not only to blow the particles off, but also to dry off the brake clean as much as possible so that I'm not causing any damage to the seals. So then I took each of the armatures and gave them a little scrub here with a soft, flexible sanding block to remove all of the corrosion and the rust. And I mean, as you can imagine, this solenoid is sitting directly on the back of the snowblower, and it's subject to a great deal of snow, ice, which melts, becomes moisture, and there will be a certain amount of salt and sand and dirt that it is subject to as well. You can see here the other side armature is considerably more corrosion and buildup on it, and there's a groove worn into this one, and I'm not exactly sure what would have caused that, since those magnets sit on, they're tight, they don't rotate, they don't move up and down at all, there's no motion. So I don't really have an explanation for why this particular one had that wear pattern in it. But I decided to clean that up as well. Whenever I take something like this apart, I clean all the parts. I won't just clean the obvious ones, but this would have been the obvious one. It had the most corrosion on it. And then it was time to, well, of course, have a bubbly break, my drink of choice. And that's a strawberry bubbly, by the way. Then it's time to clean the magnets, and they had a considerable amount of scaling and oxidization on the lip that seats up against that armature. I don't know exactly what causes this. I haven't really seen it to this level before on another solenoid. But again, since everything else looked to be in good shape, then I'm kind of left with the simple solution, which is clean it. And so more brake clean, and I just pull a shop rag back and forth through the magnet multiple times to get as much out of there as possible, and it seemed to work quite well. That rag it's tough to get it through, which means it's a nice tight fit, which means a good amount of rubbing action happens going through, and did a good job. There was a specific cylindrical brush I was looking for to clean this armature. It would have been perfect. I couldn't find it. I just saw it the other day in my shop, but I couldn't remember where. So this little part scrubber worked just fine. And it gets into all the nice little crevices. And then using a dental pick for for the descaling on the edges of the magnet. The dental pick has its place, but it's fairly light duty, and some of the buildup here was pretty tough. Now, this first magnet wasn't nearly as bad, so I managed to get the job done there with that dental pick, but it was considerably worse on the next one. So just a couple more passes through with the rag to make sure that if there's any grit left in there, and there you see it's a nice and clean. That one didn't take a lot of effort. But that's the one that hangs on the bottom side of the solenoid. This second one here is the one that's on the top side, and it's much more subject to ice and snow and sand and all the other debris that goes with snow blowing. And this one had a lot more corrosion and buildup on it. And so I decided to pull out the big guns. The dental pick wasn't quite cutting it, so I took a micro screwdriver, a flat, has a fairly sharp edge, and it worked out really well. just to kind of rotate that magnet against the direction of the screwdriver, and it just peeled all that scale and corrosion off really nicely. In fact, I had to be careful because it bit in very aggressively, so I didn't want to do any damage. But that worked out really well. And I'm trying to point out all the different tools that I used and materials such as brake clean, etc., compressed air, because I want to show that there were no special tools used to do this job. You know, right here you can see the dental pick, the slip joint pliers, that little brush, this screwdriver. We're talking, you know, the kind of thing that everybody has, or most people do, and if they don't, it would only cost a couple of dollars to get it, because part of the point of this video is we can fix a lot more things ourselves. I was looking for a video like this on YouTube. In fact, I ran into the exact same issue earlier this year on a solenoid on the back of my tractor. So this isn't my first go around. So I've already been through this, and I looked and looked and looked for videos, or even just websites where I could find information on A, exactly how a solenoid works, and B, how to troubleshoot. And there's virtually nothing. Talking to the local dealer, it's looks like you need a new solenoid. We're talking hundreds of dollars and diagnostic time, etc. So I just decided I've got nothing to lose. So I did that on the first one. It turned out perfect. And so I sort of knew where to look on this one. And I just decided that since I couldn't find what I wanted as far as tutorial videos go, I would make one myself. So this one had a bit more corrosion and buildup inside. So I decided to take my thin sanding sponge and roll it up with the abrasive to the outside, and it fit perfectly inside that solenoid, and it was a great way to just sort of hone out the inside and just clean up the last little bit of whatever might have been left. Worked out really, really well. Of course, time for a shot of bubbly. And that was pretty much it for this magnet. It also turned out nice and clean in the end, which you'll see here shortly. So just a couple more rounds with the sanding sponge, and then just in case that produced a bit of grit, another shot of brake clean, and then another pass through or two with the rag. And I was quite content that I'd gotten everything, all the debris out of there. Now, keeping in mind that this is not a moving part, so I'm not too concerned about, you know, any wear and tear from movement. So I was quite content. Then it came out nice and clean. Keeping in mind this was the worst of the two, and so it came out really well. So far I'm feeling pretty good about how all the components are coming clean and the corrosion's coming off. So you know, now it's basically just clean up the last little bit of oil, dry things off, and then start the reassembly. So basically now it's just clean up of the last few smaller parts, putting the armatures back together, and then I guess, I don't know if that's quite the right term. This is actually the armature. It's the plunger that travels back and forth through the valve body itself. So give that a quick little scrub with sandpaper as well, and then reassembled the block. And just make sure that the plunger goes back and through nice and smoothly. And then put the washers back in place. And then thread on the armatures on the end. I'm going to continue to call them that until I think of or find a better name for them. Now, there aren't really a whole lot of pieces, so it's just important to put it all back together the same way it came apart in reverse. And you know, there was 2 washers on each end and a spring, essentially, not a whole lot. So just threaded that back together, and then went over to the vise and just did a quick tighten up with a wrench. Now I just want to point something out here. If you look at the ends, right where the wrench would go, you see that flat spot? Can you see how the shoulders of that flat spot have been marred and knocked off? Clearly this thing's been taken apart before, and maybe not in the gentlest fashion. And what I'm finding is, as I get into this thing, that This isn't the first time this thing's been disassembled and cleaned and repaired. So it's kind of nice to know that I didn't do anything to damage anything. But at the same time, I hope it's not going to be problematic in the future. So what we've got left to do now is put these 4 O-rings in. One O-ring goes in each of the recessed holes. It's a really nice snug fit, and they sit proud of the face. In each of the 4 corners is a hole for an Allen bolt that holds this block tight. It has to be tight enough to squish those O-rings to get the perfect seal. It's very important because there's a lot of hydraulic pressure behind it. Initially, it almost seems as if those O-rings are too large for the hole, but you have to kind of squish them in there and compress them a little bit, and it's a really nice snug fit. It's perfect. So we've got these magnets now that slide on. And then, of course, it's time to install the magnets. They slip on nice and easy, and there's just a plastic cap that threads on each end just to hold the magnet in place. And typically you would just crank them on hand tight, but in this case I just grabbed a crescent wrench and snugged them up just a wee little bit more. Whenever it comes to plastic fittings or caps or nuts, you never want to go very tight, because that's when things crack, and then, well, then you have a problem. So that came together very nicely. And then, yeah, like I mentioned here, just a quick little snug up with the wrench. And then basically we're ready for, so it's for these Allen bolts that hold the valve body on. It's awkward to get to. I couldn't get the short side of the Allen wrench in because of all the hoses and things that are in the way. So one little trick that anybody in a shop would know is if you have to use the long side of the Allen wrench just to get in there. Here's our problem. A small wrench to give you because leverage on that Allen wrench.
The proximity
so
of these leads, these prongs here for the electrical.
Over the short side of the L
into the head of the Allen.
And you use that
I can't get enough leverage just with my fingers,
because there's only so much you can do on that short little lever.
So what I'm going to do is I'm going to use the long side.
But if you add another wrench to it, like this,
give me some leverage.
Now you've got all the leverage that you need
on my Allen wrench.
Not work that great with cheap wrenches, because cheap ones are brittle and they break when you do this.
Get the wrench.
So this is a testament to the quality of these wrenches. They're nothing special, but they are Husky wrenches from
gives you a lot
Home
of
Depot. One of the very few Husky tools I own.
I can get all
but they actually handle.
So we'll do it again here.
Shucks, I've had these wrenches for close to 15 years, and I've yet to break one. I have lost one or two, but I've never broken one. So, and they are ball end wrenches. A ball end wrench is nice because you can get into the head of the screw without being perfectly square to it. It gives you a bit of room to swivel when you are in the head of the screw. And it's just a little bit easier to work with that way. So I really like this set. I've got a lot of Allen wrenches. This is the only set I have that has the ball end. But when you need it, you need it. So pretty pleased with that. So then it's time to hook up the leads. It's just a 3-prong plug. Just make sure we plug it back on the same terminal that it came off of. Sorry about my arm in front of the camera. It's tight. It was hard to get a good camera shot of this one. But it's pretty simple. You just plug it back in. One Phillips head screw to hold each one in place, and that was it. So basically, that was the end of the solenoid work. Then it's just a matter of reconnecting the hydraulic hoses. It is a fully hydraulic snowblower. And these 2 main hoses you see on the loader arms are fed from a 3-point PTO-driven hydraulic power pack on the back of the tractor, which I will most likely make note of in a future video. And then these 2 leads here, these electrical lines that I'm dropping into the cradle.
Right, so this is actually a great opportunity to show what can happen. So I guess
as I disassembled the loader, the snowblower to get it off of the tractor earlier,
one of the pins
I didn't realize I had actually pulled a terminal.
And they have these little barb
or a pin out of the back of the plug.
Fittings right there. Not
this
fitting,
pin has 2 small metal tabs, which act as barbs to keep that from happening. But I guess it happened, and so I had to push the pin back into the back side of the plug. And what I'm doing here is trying to push those tabs back out, those barbs, so that it will hold better in the back of the plug. Because when they are active, when they come into play, as soon as you push this pin into the back of the plug, it actually snaps in. You can feel it, you can hear it. and you get a nice good solid connection. I use a screwdriver here to really push that pin in and seat it nice and tight.
It looks like it's
and
seated
that's called a Deutz connector. It's a good quality connector with a triple lip rubber seal. And I've never had any trouble in this industry with the many pieces of equipment we sell. I've just never had a problem with getting moisture into those plugs. They're very good quality plugs. There's cheaper knockoffs out there. They seem to work fine too. I've used some of them, but the original is called a Deutz connector. So I got the leads hooked back up, and then it's time for a test. So as you can see, it is now pivoting to the left, which it didn't do before. And you'll see as it pivots to the right, the chute also is traveling up and down. So success. Very pleased with the way it turned out.
All right. So it works. Very happy about that. Solenoids are expensive. I don't like spending money on stuff I already own. Prefer to fix it if I can. And I am no great mechanic. There is a lesson in this. And that lesson is anybody can fix many things. If I can, so I'll tell you what happened. I have a solenoid valve on the back of this tractor that operates my 3-point top link off of a joystick button in the cab. And it quit working on me earlier this summer. And I needed it. I need that hydraulic to change the pitch and angle of all my rear attachments, whether it's a grading blade or the tiller, anything. And I've never fixed a solenoid before. And I was frustrated, but I got some good help from the dealership on the phone to eliminate every other possibility. And what was left was the solenoid valve has to be failing somehow. And it's extremely rare for a solenoid valve to fail. They're bulletproof. So I'm just doing this logical, deductive thing, saying to myself, it's got to be something simple. It's got to be something simple. So I took it apart. I didn't know anything about solenoid valves. I Googled a bunch, watched a bunch of YouTube videos first to understand how the valve worked so that I knew what to look for. And when I opened up that valve, I didn't find a thing. Nothing. No, it was way better shape than the one I took off the front here. There was no scoring, no scratches, nothing. It was perfect to the naked eye. But I'm thinking to myself, the way these valves work is it's an electromagnet that pulls on that armature to open and close the valve or change direction. But actually, it's a little spring in there that pushes it back to the center position. And that little spring has to be strong enough to push against all that hydraulic flow. So if there's even the smallest obstruction, we have very, very sandy land here, and even the smallest bit of grit, had it somehow gotten into my hydraulic oil, somehow. And by the way, I checked my oil. It looks good. It's clean. Regardless, something was blocking that valve. And I thought, well, I've got it apart. I might as well clean it. So I cleaned it, put it back together, and it works perfectly. That was my experience. Well, when I was out blowing snow the other day and my chute quit turning, and I'm thinking to myself, it's got to be something simple. So today was the day. And I do sometimes get a little intimidated by projects like this. It's electronic and it's hydraulic. And those are two things I don't have a ton of experience with from a hands-on standpoint. I sell agriculture machine for a living. I grew up on a farm. I've run just about everything out there that's got wheels and hydraulics. I can run the machine, but I'm not a technician. I've never worked on stuff. I mean, changing tires and changing oil, that's about it. The lesson in here is anybody could have done what I did today. I didn't use any special tools. Allen wrench, a Phillips head screwdriver, some small dental picks, which you can pick up anywhere, and brake clean, a little bit of sandpaper. That's about it. A vise, a bench vise. Could have done it without the bench vise, to be honest. Crescent wrench, slip joint pliers, stuff that just about everybody has at home. I guarantee you the process that most people would have followed, and this is not a bash against anybody, and this is no kudos to me, but I work in the ag industry. I see this all the time. They would have brought the tractor in, but not everybody even has a trailer to haul a tractor this size. So they might have hired somebody to bring it in, okay? Spending money. Then you bring it into the shop, and it's a minimum 2 hours diagnostic fee at $135 an hour. So now they're into it for $270. They might diagnose it in 5 minutes, but it's a minimum 2 hours. However, generally they will apply that towards the repair. They would have found nothing, guaranteed. So then they would have said, it's probably your solenoid valve. best to replace it to be safe. Okay. I don't know how much they are. I'm going to guess $300, $400, $500. They're not cheap. So now you've got your $270 diagnostic fee, and that'll probably cover the removal and replacement of that valve. But you're going to be into this by the time you've transported it there, minimum $300, probably more like $500, $700, $800. You probably notice it's a John Deere. All right. There's a premium for running green. And the only reason I have it is because it's a great little tractor. It came with a bunch of attachments. I got a smoking deal. It's a great package. I love the tractor. Don't get me wrong. But you pay a premium for green. So if you go to the green dealership, you pay a premium. You pay a premium for parts. You pay a premium for labor. You pay a premium for everything. I'd be surprised if their shop rate wasn't higher, considerably higher than the $135 I just said. So the lesson is, okay, it cost me, and I'm making a video. Videos take time, right? I got to move the camera, stop and start. So I didn't rush through this. I don't think I spent 45 minutes actually working on the valve. What's my time worth? I don't know. If I get paid really well for a side job, I want $50 an hour. 45 times 50, well, it's like $35, $40 of my time to save $500. I think I got paid really well. So anyway, I'm really happy it turned out. I don't really have a lot of snow to blow right now. I got a few edges to clean up from the wind that we had, and I'm excited to go and try it with a chute that turns in both directions. Thanks for watching.